Hello everybody, welcome back again to the LSD-SLAM with drones series of videos. In this case, this is the fourth video of this project I'm doing. Let's see if finally this is the last video and we can achieve to perform LSD-SLAM correctly with a drone. Let's see. So if you remember from the last video, we were trying the LSD-SLAM node, LSD-SLAM packages with an Hector Quadrotor simulation, which we managed to have it working. But if you remember, we had a problem with the location of the camera. We were having some noise there because it was capturing the part of the drone, which would lead to errors. Let's have a look to refresh better this. So let me open here a web shell. I'm going to open as well a graphical tools window. I'm going to open it in a new window to visualize it better. Let's log in here. Okay, there we are. So let's close this. And yeah, let me refresh the command. It was okay, yeah, here we have it. So this is the command in order to launch the node. So let's do a ROS topic list to get the camera topics. There we have them. So yeah, let's try to execute this command to see what we got, to see what was the point where we left it in the last video. So here we have the camera info topic, and then we need the image stream topic, which goes here. There we are, and which is called image. Well, let's of course launch first the simulation, because if not it will be difficult to visualize something. So yeah, let's launch our simulation, which was the camera launch. I have it here. Okay, so yeah, let's launch our simulation and let's start opening an IDE as well, because we are going to be using it. Okay. Okay, so oops, I've added here a cylinder. Okay, so yeah, let's launch now the node. Okay, there we are. So yeah, as you can see, we are detecting here the part of the drone, yeah, which this obviously will lead to errors, yes, because yeah, our drone is not part of the environment, so we don't want to have this always as part of the environment, yeah, because this will obviously introduce errors into the maps that are being created and into the SLAM that is being performed. So we don't want this, yeah. So how can we solve this? First of all, for instance, what we should do is to move the camera, yeah, move it a little bit outside of the robot so that it doesn't detect the drone anymore. So for that, let's open here the IDE. Okay, let me find here for the URDFs, and okay, yeah, so yeah, so the launch we are using is the camera launch, which is this one here. Okay, so from here we can start searching, and we can see basically right here that the URDF that is being loaded is this one here, the Quadrotor Hokuyo UTM30LX gazebo.chakra. Yes, so where do we have this chakra file in this case? So it's in Hector Quadrotor description, which we have here inside the URDF folder. Yeah, so this file here, we can see it right here. So let's open it, and this one is inside loading this Quadrotor Hokuyo UTM30LX URDF chakra, which we have just right below here. So let's open as well this one, and inside here we can see that it's loading yet another URDF, this Quadrotor based URDF chakra, and here it's also including the URDFs for a Hokuyo laser and for a camera, the generic camera, which is the camera that we are visualizing. Yeah, so here, as you can see, in the origin XYZ, we can choose where to place the camera. Okay, so I'm going to move a little bit this camera in the x-axis. So for instance, let's move it 30 centimeters. Let's save this file and let's relaunch the simulation and see what happens now. So let's come again here and launch again our simulation. Let's see if now our drone is not detected anymore by the camera. Yeah, which will allow us to perform LSD-SLAM without introducing any errors. Yes. So let's see, let's wait a few seconds until the simulation is fully loaded. There we have it. And now let's execute again this command and see what happens now, what we get now. Let's see. Okay, excellent. So as you can see, our drone, yeah, the upper part of our drone is not detected anymore by the camera. So this is what we want. This is what we need in order to be able to perform LSD-SLAM. Okay, excellent. So besides that, as you can see, right now it's not detecting anything, and this is because the environment we are in, it's quite very similar. Yeah, so it's hard for the LSDAM system to detect edges, different textures, etc. Yeah, so that's why anything is marked here. So another thing that we should do if we want to be able to perform this LSD-SLAM is to have an environment, a world with more textures, yeah, with more different parts, so that the camera is able to detect different textures, edges, and places where it can keyframes, in fact, yeah. So it can detect keyframes in the image, which will help him to localize itself within the simulation. Yeah. So for that, let's change this environment, this world we are in. Let me stop this for a moment. And then let's come again here to the IDE. Let's close the URDF files. We don't need them anymore. And here, as you can see here, it's where the world is being launched, this Willow Garage world. And it's in the Hector Gazebo worlds, which is, I think it's inside here, in Hector Gazebo. Yeah, here we have it, Hector Gazebo worlds package. And here we have the Willow Garage launch file. Yeah, so inside here, basically it's starting a world, which is the Willow Garage world. Yes. So, okay, let's copy the contents of this file and let's create a new one right here in the launch directory. Let's create a new file which we are going to call small village.launch. There we are. Then inside this we are going to copy the contents of the Willow Garage launch file, but we are going to change here the world argument. So let's, for instance, put the, I don't know, the CVG sim gazebo package, and inside here I know I have a world which simulates a small village with 3 houses. So the world is called, if I'm not wrong, if I remember correctly, it's called RDrone Test World. I think it's called like this. Okay, let me make sure by going to that package, ROS CVG Sim Gazebo. Worlds. Okay, so it's rdrone test world.world. Let's see. rdrone test world. Okay, yeah. So it's well done. Okay, so yeah, I have this small village launch file, which now it will load this world, which it's a small village. You will see it right now. And okay, so let's close this. Let's close as well this, and now let's change here in the camera launch to select our new launch file, which is called small village.launch. Yes, there we are. Excellent. So let's test this. Let's close our simulation and start a new one, and let's see if everything goes fine and if our new world is correctly loaded. So let's see. Let's wait a few seconds. Okay, so it looks fine. Yeah, excellent. So as you can see now, I have changed my environment. I am loading this small village. Yeah, whoop. Here we have it with a couple of houses, and there it is, our Hector Quadrotor drone. Great, so yeah, let's launch now again our LSD-SLAM node. Here we have it. And let's see, what do we get? Okay, there it goes. Okay, excellent. So now, as you can see, the camera actually is detecting something. It's marking here some key frames of the image, which will help the drone to localize itself, so to perform a SLAM. Yes. So great. We have our debug window open here. Let's open as well the viewer, which I have the command somewhere around here. Here it is. So let's launch the viewer node as well. Let's open a new shell in order to start the viewer. And actually we will need yet another shell in order to move the drone. So let's put it also here. Okay, so here we will launch the viewer, where we will be able to see the map that is being created and the position of the drone. This red mark is the estimated position of the drone, yes. And then, if everything goes fine, here we should be able to see the map that is being created from the point cloud, yeah? So let's see if everything goes well. And now here I'm going to launch the teleop twist node in order to move the robot through the keyboard. So the teleop twist keyboard, there we are. Let's launch this. Oh, excuse me, first of all I need to take off the drone. So for that I will need to publish into the takeoff topic. If I do a ROS topic list here, you will see that I have a takeoff topic, and there's also a land topic somewhere here. Here I have it, the land topic. These topics are used either to take off or to land the drone. So before moving it, I will need to take it off. So let's publish into this takeoff topic. I know it uses empty messages. So let's publish an empty message here, and you will see how the Hector drone takes off. Let's go. There you have it. Excellent. So now, yeah, now I can execute the teleop twist keyboard node. There we are. Great, so now I will be able to actually move the drone. Okay, yeah, here you can see how it's starting to add some things there. Yeah, some things to the map. But let's actually move a little bit more the drone and face it to the houses, which will be better for the LSD-SLAM. So let's lower a little bit the default speed here of the drone. And let's turn it left so that it can start visualizing the houses. Let's see. Okay, there we are. So now it's seeing these houses. Excellent. Let's yet move it a little bit more. And let's go forward. Okay, so it's getting closer to the house. As you can see, it's detecting a lot of points there. Okay, excellent. Let's stop it around here and see how it is going. Okay, this looks quite good actually. It's, as you can see, it's there starting to put all the points there in the map. Yeah, here there it is detecting all these squares, as you can see there. Okay, yeah, so it's kind of detecting this house. As you can see, this red mark here is the current position of the drone. Yeah, so if I tell it to go forward, here the red mark moves forward, as you can see. Yeah, if I tell it to, oops, sorry, okay, there we go. If I tell it to go backwards a little bit, as you can see, the red mark begins to go backward. Yeah, so this red mark is the current estimated position of the drone, which is quite good, as you can see. It looks like it is working quite well. Also, the houses are being added here to the map, so this looks like it's working very well. Excellent, excellent. So yeah, I think we have done it, guys. I think we have managed to perform LSD-SLAM here. You can of course keep moving the drone through the simulation. You can go up, for instance. Now I'm going up, as you can see. Okay, there we are. Probably if you move the drone to, if you face the drone, I mean, to somewhere where it doesn't have many keyframes in the image. So for instance, let's see what happens if I move it here. Yeah, well, it doesn't get lost actually. It's keeping the... Okay, yeah, there we are. Let's see. Oh no. It didn't get lost, so it still knows where it is. There we have the map. Let's turn it let's face it to this other house we have here and see if it keeps localized. Let me try it very quickly. There we are. I'm turning it right now in that direction. Let's see. Okay, so there it is. It isn't detecting any keyframes there. So probably it... Okay, there we are. I wanted to force this. So here it lost the track of the drone, yeah? So if this happens, for instance, well, you can just stop this and restart it, probably, and it will start everything from zero. There we are, yeah. Now it's... yeah, so depending on if you move the robot very quick, probably it will have some errors, because this is not super accurate or super powerful, yeah. It's a little bit, let's say, delicated, yeah. So, but well, yeah, we have seen that it's working quite well, yeah. I'm currently surprised of how this is working, because the localization of the robot is quite good. Also, how it's building them up, it's quite good, as you have seen. So yeah, well, we have it working, so you can feel free to test it yourself, to download this simulation, modify it as you have seen I have done during this series of project videos. And well, you can try to build a map of this small village. And yeah, send me your results, send me your videos, so I can see how you are doing, if you have managed to achieve this as well. And well, I hope you have liked these videos. I hope you have enjoyed these LSD-SLAM project videos. I hope you have also learned something from them. And well, see you very soon in another project. Goodbye.